Good afternoon, Year 8. As the title suggests, we're going to continue looking at solving equations today with x on both sides. So if you want to write down the title of solving equations, let's go. So basic idea is if we have x on both sides of the equation, then we need to change it so that there's just x on one side of the equation. And the way we do that is to add or subtract amounts of x. So let's look at these first two examples. First one, we've got 3x is 14 plus x. You make sure you copy these examples down too, sorry. And we generally want to look where the highest positive amount of x are. There's 3x on this left side and only 1x on this right side. So we're going to try and get our x's across to this side, to the left. So we're going to subtract x from both sides. That will reduce us to 2x on the left, but it will also just completely get rid of the x's on the right hand side. That'll give us 2x is 14, x take away x is nothing. From there, just divide by 2 and you'll get x is equal to 7. For the second one, again, where is the highest positive amount of x? It's again on the left hand side. 7 is definitely more positive than minus 5. So we're going to get rid of this minus 5x, and again, remember we do opposites to do this. We're going to add 5x to make that happen. That'll give us 12x equals 48. From that, divide by 12 and we'll get x equals 4. Two more to think about. So on the first one, we've got a case where we have to expand the bracket first. So let's do that. 7 times 2x is 14x, 7 times 5 is 35, and that leaves us with 4x. Again, we're going to want to get the left hand side in here. There's definitely a greater positive amount of x on the left side, so we're going to subtract 4x from each side. That'll give us 10x plus 35 equals 0. And then we're not going to divide straight away because this doesn't say 10x equals anything. We're going to have to move that 35 across to the other side. So we'll get 10x is minus 35. Final step would be to divide, obviously, by 10, and that'll give us that x is minus 3.5, or 3.5 if you want. And then the last one, we've got fractions. And now there's a lot of ways you can deal with this. You could give them a common denominator. That's certainly a way we can add or subtract things together. But I prefer to change things to decimals if possible. So instead of writing x over 2, I might write 0.5x. Instead of writing x over 4, so that's a quarter, I might write 0.25x. And this will just make it a little bit easier to deal with. Again, where is the highest positive amount of x? It's on the left. So we're going to subtract 0.25x from each side. If you do a half, take away a quarter, you've got a quarter left over. So we got 0.25x equals 2. How do we get up to a positive amount of x? Well, we would times by 4. We've got a quarter of x, we want to get to a whole x. X would be equal to 8. Do remember, of course, you can check any of these works. If I was to put 8 back into this equation, this would tell me 8 divided by 2 is the same as 8 divided by 4 plus 2, so 4 equals 2 plus 2. Yeah, that works. So if you're not sure if you're right, you can always check. Okay, so some questions for you to do then. So same as normal, I will periodically put some answers up, but if you want to pause the video now, maybe try the first 2 and then unpause, then we'll show you the answers in 3, 2, 1. There we go. So these two are a little bit different in that the greatest positive amount of x was on the right hand side. So we ended up with the x's ending up on the right, and that's absolutely fine. We'd read our final answers as x equals 4 and x equals 6. Okay, try the next 2 and unpause in 3, 2, 1. There we go. So again, we had all the greatest amount of x on the right hand side in the first question, on the left hand side in the second one. If you come up with a different method where you are doing the same to both sides and you're getting the same answer, then that's valid as well. So there's lots of different ways of approaching these questions. But this is just the way I think is most straightforward. Okay, so 4 more to go. Unpause when you're done. I'll show you the answers in 3, 2, 1, and there we go. So On this one, I think 11 is probably worth a look. Remember that you can always give your answers as a fraction. You don't need to actually work out 5 divided by 6. You can just leave it as 5 over 6. And I think 12 is worth pointing out in that if you do end up with a fraction, you can always simplify that fraction. So minus 12 over 16, we can divide top and bottom by 4, and we can get ourselves to minus 3/4. But any method you use that got those answers is fine. Okay, one last sort of examples to look at. So if we have got x on both sides and so on, and we've got numbers on both sides, we just have to kind of do 2 levels of subtraction or 2 levels of addition here. So let's look at this first one. I'm going to subtract 2x because the greatest positive amount of x is on the left hand side, and that'll give me 7x and nothing. But also, I would kind of like the numbers to be on the other side, and I can do this all at once. I can subtract 6 from both sides as well. So I'll end up with 7x equals 14. And then all I need to do is I need to divide by 7, and I'll get ourselves to x equals 2. Second example, I can do sort of the same thing. Which side do we want the x to be on? Which has got the greatest positive amount of x? It's this one, isn't it? 6 is definitely bigger than 2. So we're going to remove 2x from each of them, and we're going to move the numbers to the left hand side. So we're also going to subtract 4 from both of them. What will that give us? That will give us minus 12 only on the left hand side and 4x on the other side. So if we divide by 4, that will tell us that x is minus 3. 2 more examples. Where do we want the x to go on this third one? Here, minus 8x is a more positive number than minus 26x, so we're going to add 26x to each side. What about the rest? Well, we've got 4 and 1, so we need to obviously subtract the 4 because we want the numbers to be on the left. What will that give us? That will give us 18x equals minus 3. And then how do we do this? Well, we just divide by 18 and we write it as a fraction, and we see if we can simplify that fraction. So it's minus 3 over 18, which does simplify to minus 1/6. What about the last one? Well, we've got brackets, so probably the first thing we should do is expand those brackets. We'll get ourselves to 6x plus 15 is 18x minus 6. Which side do we want the x's to go on? This side here. 18 is bigger than 6. So we'll take away 6x from both sides. Numbers need to go to the other side, so we'll add 6 to both sides. We'll end up with 21 equals 12x. What do we do from there? We divide by 12, and we'll end up with 21 over 12 is equal to x. Can we simplify that? Yeah, we can divide both of that by 3. Simplify to 7 over 4, or I think that's 1 3/4 if you wanted to go to mixed numbers, but you don't need to. Okay, so slightly trickier examples. Can we make sure those are copied down? And then whatever time is left in the lesson, I'd like you to try these questions here. Obviously, when you get to the end of your 35 minutes, that's the point you stop. I'm going to show the answers for the first 3 in 3, 2, 1, and there we go. Again, you can get fraction answers, so don't worry about that. You could also have 1.8 for question 3. Okay, let's show the next 3 in 3, 2, 1, and there we go. Nothing too fiddly there, just make sure you're adding if you need to. And then the last 3, I'll show you in 3, 2, and there we go. Okay folks, have a good day. There's a homework set, so make sure that's done as well. I'll hopefully see you next week.